Hi everyone, Dr. J here, and in this video we're going to go through Python imports and functions. Now we've already seen a number of examples of Python functions, including the print function and the type function. We've seen that functions can take a variety of inputs, so we can print a string as is here, or we can print a number, or any other number of Python objects, such as a list. One thing that we haven't mentioned is that a function must have these open-close parentheses. So if we run this, nothing will happen because there's nothing to print. But if we take away the parentheses and run the function by itself, all we'll get is function print. Now if we say type print, it's a built-in function or method. So we can see that print by itself is just not doing anything in terms of running. We're just getting back what type of object print is. It's a Python function. Okay, another useful function is len. Len gives you the length of a list or the length of a string, as you can see here, and really the length of any Python object which makes sense to have a length. Now before I go on, I want to show you just a compendium of other Python built-in functions. These are all functions that are available in Python without importing any external modules or packages. So what do we have? We have format, for example, float, filter, exec, bin, axi, any, all. These are all Python functions that you can call and use within Google Colab or any Python editor, and they'll be available. What do these functions all do? Well, for example, we can take isInstance. We can pull it over here to Google Colab, and let's get a new cell. And we can type question mark function, and then we can run that, and that will give us the help message for that particular function. In this case, isInstance checks to see whether an object is an instance of a class or of a subclass. So for example, we can say isInstance a string, str, and we'll get true. If we say float, we'll get false. So this web page is just from the Python 3 documentation functions. You can see the list of built-in functions there, so that's useful to explore at some point. Most functions, however, in Python are part of libraries, and these libraries can be imported using import library name. So for example, import os.getCwd. That will tell us the current directory that we're currently located in, and this is in Google Colab, so this is some remote directory somewhere. But you have to first import this package, and then we can reference functions in that package using the dot notation. So you can see if you put the dot, you can see all the different functions that are in OS. Some of the ones that I use regularly are makedir or path. Path is actually a submodule, and it has its own set of methods in there, and you can see those here. So for example, abspath, dirname, exists. These are all things that you can use for I/O. This is this location where we are right now. And you can even use variable assignment here. So for example, current directory equals os.getCwd. So we can check for the existence of a directory, we can make a directory, we can change file names and do all sorts of things using this OS module. There's other very common modules. You can do things like interact with your computer system, interact with the user of your code through user interface, and so on and so forth. Another common Python package is math, and that has a lot of math functions. I tend to not use math so much because I use NumPy, which you can see right here, instead of that. But math has a lot of the very basic math functions and works quite well. And you don't have to install NumPy if you don't have it installed by default on your machine. And there are a lot of other modules as well. In fact, let me just come over here to the Python standard library. The Python standard library are functions and modules that are available in Python by default. And you can see a lot of things are in here. So we have Booleans and type operations, regular expression operations, string operations. A lot of these have to do with low-level computer operations, but some of them are, for example, calendar items, date time, basic date and time syntax and types, copying variables, graphing things, numbers. There's the math module that we mentioned, complex numbers, CMath, statistics. There's a statistics module. Itertools, functools, and operator are all functional programming modules. These are things that are used in more advanced programs. This is all part of all the default Python options, and all these things are available, so you should check out the Python 3 documentation. Okay, so let's come back over here and let's look at some of the more common examples of imports that are not in the standard library. So NumPy is a Python package that uses all sorts of numeric mathematical operations and makes matrix vector mathematics available, and is really kind of an equivalent to MATLAB for Python. That's NumPy. Matplotlib is a Python plotting library, and that can be used to make all kinds of different plots. You'll see the references to those in the main Canvas page. So we can run this and create a very simple plot and make that plot. Okay, so that's something about existing Python functions and existing Python libraries. Oh, and I do want to say before I move on, other very common external Python libraries include SciPy, Cartopy, which is for mapping. SciPy, as you can imagine, is for scientific computing purposes, but this includes things like interpolation and all sorts of mathematical operations like taking gradients and integrating things, some basic kind of statistical things, and machine learning things. So SciPy has a whole ecosystem. There's all sorts of I/O libraries. Pandas is a Python package for manipulating spreadsheet data and CSV data, and is really the Python equivalent of a spreadsheet program. And so basically what I recommend is that if you're doing a particular task, just Google whatever that task is in as specific terms as you can, and then Python, and chances are good that if you're doing something that is very common, that someone else has already done it in Python and you can use that. Okay, so now we want to think about defining our own functions, and there's a particular syntax that we need to use to do that, and that's given here. So every function starts with the keyword def, space, the function name, open parentheses, any input arguments that you want to pass to the function, and then close parentheses, and then a colon. This tells Python that this is a function definition, and all of the indented code below this line is going to go with this function. In fact, let me say this. So here we have 2 lines of indented code, and if I say something like this outside of that indented block, even if there's no space, if I don't have an indent there, or if the indent is not matching the indent level of the rest of the indented block. Okay, so if the indent of this line of code does not match the indent of the indented block inside the function, that line of code will not get executed with the function. And if it's after this return statement, it will also not get executed. So we can go ahead and run this, but it's going to give us an error because we haven't defined this out. And you can see here, well, out is right here, but because this is inside a function, this line of code is outside the function, and so we have an error because we haven't defined out outside of the function. So let's try doing something like simple sum 1, 2, 3. Now we can run this code, and we'll actually get a value for out. And there we have a value for out. So we've defined out outside of the function simple sum, and now we can use that function and use that variable and manipulate it. And everything that's happening inside this indented block is happening inside the function. Once we have run the cell containing the function definition, we can call that function from any other cell. So we can again call it here. And this cell, you can look it over. This keyword args, star args, is a way of passing multiple functions, multiple inputs. We don't have to specify the number of inputs. We can use 2 inputs or 3 inputs or no inputs. As we've already said, you can get help with a function by using the question mark sign, and I will not go into that at the moment. We can use our own functions to improve and build on what Python provides in their functions. So Python has this plot function, but it has a whole set of commands, and we might want to specify particular things for a whole suite of commands together, and we can put all those commands together into a single function, which then we can use to make a plot like this. And you can see here the example of what that plot would look like. And now we have a very nice simple interface to that plot if we wanted to make it multiple times, whereas we would have to put in all this information or type all these lines of code if we wanted to do that multiple times. Now we have defined a function to do it for us, and we can do it all very easily multiple times. So functions are really about reusable code. If we have a piece of code that we want to be able to use in multiple places or at multiple times, then we write a function. Okay, and here I ask you to do some experimentation writing your own function. We can also install, one thing to note is that we'll be using Google Colab, and so you'll need to install some of the packages that we'll be using. And whoops, I'm trying to do this here. Here we go. So we can pip install geostatspi. That's a Python package for geostatistics that we can use in this course. And we can do all sorts of other fun and work-related things in Python. And this just asks you to check out some different Python packages and try to install them. Now, Python functions and flow control go together. And I say here, you can write a function that executes on a single number and then apply it to a list. This is a very common application of Python functions, where we want to just do an operation on a number, but we might have a whole set of numbers that we want to do this same operation on. And so what we can do is we define our inputs, and then we can specify an empty list for an output, and then we can simply use a for loop, iterate through this for loop, so for n in number list. So this is going to go one by one in number list and take the numbers. And what we're going to do is append to the output list the output from the function evaluation on each number. So again, we create a set of inputs, we create an empty output list, we iterate through the list of inputs for n in number list. We're going to go through each number in number list. We calculate our function output from that input and append it to our output list. And then if we print the output list, we get what you can see there below. Whoops, and I haven't defined my function yet because I'm going through here too fast. So now that we've defined the function, now we can print it out and get this list. Usually, though, we won't want to print out an actual list. We'll want to plot the data. And so we can do this, of course, using this matplotlib plot function. Now, one thing I haven't emphasized too much yet, but I want to make sure you understand it, is when you import a module. So when we say install, that installs the package, but it does not import it. So we would have to then say import Cartopy, or some various submodule within Cartopy. So we have to install it, then we have to import it. So up above here, we have imported matplotlib.pyplot as PLT. So we're just using this as keyword when we're importing things. We can import packages as a shortened version that makes it easier to type. So we can say import matplotlib.pyplot. We don't really want to spell all of this out every time we call matplotlib.pyplot, so we're going to import it as PLT. And these, at least for NumPy and matplotlib.pyplot, these are kind of standard names. So NP is a standard name to import NumPy as, and PLT for matplotlib.pyplot. So we have to, so if those packages need to be installed, we have to install them. And then they need to be imported. And then once we've imported them, then you can see how we're calling them. PLT is the module, and then plot is a function within that module. And we can see functions in a module by just saying plt dot, and then Colab will give us a list of functions that are in that module. You can also do dir. So if we use a function called dir, we can see all of the functions that are in PLT. So the module PLT has all of these different functions in it. Another common scenario is to have different functions for different branches of a conditional statement. So here again in our flow control is we have a for loop, as same as before, but now we have a conditional. If n is less than 0, we do one thing, we pass simple fun of negative n. And if n is greater than 0, we do something else. If n is equal to 0, we do just 0. And by running this, we can see that we get this absolute value function. So this is kind of a complete look at what your programming in Python will often look like, where you're doing something to a set of numbers, and by iterating through a for loop, maybe there's some conditional statements where you have if-else statements, and then depending on what the condition is, you'll apply a function to that particular input. All right, so what I ask you to do here is to practice on your own. Take some numbers and loop through the numbers, subtract the mean, and apply these operations. And the output of these operations is to calculate the variance of this set of numbers. All right, so with that, I will wrap up and see you in the next video.